Okay, they give you a series. They tell you it is a Taylor series. It's centered at 0 because it's a Maclaurin series. And then they ask you, which one does this series represent? Which one does this series represent? So how would you go about doing this? How would you do it? Those of you guys online, can you guys hear and see my screen?
Yes.
Okay, good. Thank you, Franklin. All right, how would you guys go about this problem? I would just guess. I would just guess. I would look at it and say, let's just go with one. Okay, which one would you guys like to go with? Let's just go with one. You guys pick one. A. Okay, so what you do is you say, okay, there's sine x right there. So what is sine x? Sine x is equal to, okay, remember sine x is your odd function. It starts with x to the 1. Okay, so that's just x. And then it alternates in sign. Okay, so it's 3 factorial plus x to the 5th, 5 factorial minus x to the 7, 7 factorial plus dot, dot, dot. And then you want to multiply everything by negative 3x, right? Guys, when you multiply, you actually have to multiply the whole thing by negative 3x. But when you add, this is kind of strange. If I added, so if I said sine x, or subtract, if I said sine x minus x, when you, can I just copy? Well, anyway, when you subtract, all you have to do is subtract once. You don't have to subtract like minus x, minus x, minus x, right? So I just want to make sure you understand, because this is a big deal for students for some reason. When you multiply, you have to multiply the whole thing. But if you subtract, you just tack on a subtraction, or you just tack on an addition, okay? That's just math properties, but students have trouble with that. Students think they have to subtract x from every term. That's not how this works. All right, so I'm going to multiply every term by negative 3x. So then on the right side, I'll have negative 3x squared minus, negative 2 times negative plus 3x, x times x, you add exponents, minus 3x times x, you add exponents, and then positive x times x, you add exponents. Okay, and I know there's a general term here, but I'm just going to keep on moving. And then you add 3x. Now, what did I say about adding 3x? You just tack it on at the end. Okay, so if I add 3x, so what I have is 3x sine x plus 3x, 3x squared. If I add 3x squared, these terms go away, and this is what I get. So does that look like that? No. Okay, let's try another one. Which one do you think I should try next? D. Okay, so let's look at D. And guys, it's just really random. You just try it and you see what happens. Okay, e to the x. Do you know the Maclaurin series for e to the x? Okay, what does it start with? 1. Does it alternate in signs? No, and the e to the x is great because it's really every cosine and sine term, but you just put plus signs in between. That's nice, not alternating in signs. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x4 over 4 factorial plus dot, dot, dot. And then you multiply everything by x squared. Okay, when you multiply though, that means you actually have to multiply the entire side. Okay, if you add or subtract, you just tack it on the end. But when you multiply, you actually have to distribute. Okay, so this is going to be x squared plus x cubed plus x. Okay, x squared times x squared, you add the exponents. X squared times x cubed, you add the exponents. Oops, that's a 3. And x squared times x4, you add the exponents. Okay, then what do? I multiply by x squared. What else do I have to do? Subtract x cubed. When you subtract x cubed, make sure you understand, you just tack it on. So I'm going to subtract x cubed from that side. I'm going to subtract x cubed from that side. Do you see these terms go away? Okay, what else do I need to do? Subtract x squared. I'm going to subtract x squared from this side. I'm going to subtract x squared from this side. When you add or subtract, you just tack it on. You don't do it to every term. All right, you guys tell me, did I get the same thing as I have up here? Yes, okay, so that is your answer. Okay, this to me is just, you just guess. Yes, Mateo. Oh, maybe, but it could do other things like, yeah, maybe, but had you had like e to the negative x here, that would have turned it to an alternating sign. Or does that make sense? Yeah, so you just have to be careful, but maybe. Yes, that's a good point. All right, yeah, Mateo said, we knew it was an e to the x because the signs didn't alternate. Maybe, yes. Okay, let's look at another problem. Let's see. Okay, let's look at this right here. So what we're going to do today is talk about that. You know, since sine x is actually an alternating series, we can actually use the alternating series remainder theorem. Okay, so they'll combine, like the AP test will combine Taylor series with the alternating series remainder theorem, which we learned in the last unit. So let's talk about how it'll do that. You need to know that sine x is really hard to calculate. Sine x is very hard to calculate because who knows what sine 3 is or sine 5 is. But if you can make it equal to a polynomial, it makes it a lot easier because we can estimate polynomials a lot easier. Like we know what 1/3 is, right? We know what 1/5 is, okay? So this is why Taylor series is kind of useful. And then it also forms algorithms that you can use for computers and other things, okay? So here we have the Maclaurin series for sine x, and we want to know what sine 1 is, okay? So it says use the Maclaurin series for sine x. Find what sine 1 is, and then find the error in your approximation. All right, let's just start with sine x, because they said use the Maclaurin series for sine x. So here we go. Sine x is an odd function. So you start with x to the 1, okay? So then it just goes, alternates in signs. Everything is odd. It starts with x to the 1, and it alternates in signs. Okay, I don't know how many terms I need, so I'm just going to stop here, and I'll add more if I need to. They want you to approximate sine 1, though, not sine x. Guys, if I have sine x, how do I get sine 1? Yeah, everywhere there's an x, you plug in 1. So what I get is sine 1 equals 1 minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial plus dot, dot, dot. Okay, now I have an estimate for sine 1. But they're telling me estimate so that my approximation has an error of less than 1 over 1,000. So I need my error to be less than 1 over 1,000. So do you remember alternating series remainder? What you do is you find these denominators. So that's 6. This is 120. This is, what is it? 50, 40. Okay. So what I need to do is find the number that's less than 1 over 1,000. Let me make sure you guys understand this. Actually, you could, this right here is called my function. A lot of times they call it your function. Okay, sometimes they call it your actual value. This is your actual value. This is what you're trying to estimate. This right here, I'm going to draw a line right here. Okay, and the alternating series remainder theorem says that if my series converges with the alternating series test, then if I draw a line, if I call this, it's called the approximation. So this is called the approximation. Sometimes it's also called the estimate. They may have other names for this. But if I use this as the approximation to approximate this actual value, all of this right here, okay, this right here is called the remainder. Okay, you know, everything that I'm wrong by, it's also called my error. Okay, there may be other words. If you guys can think of other words, let me know. All of these sums here is called the remainder. My error, the maximum my error can be, if I call this an approximation, is the next term. Like wherever I put this line, is the next term. So this is the most my error can be. But guys, that's called the alternating series remainder theorem. And it's only true if some things are true. And those things have to be, the terms have to first alternate. The terms have to second, do you guys remember? Have a limit of 0. And third, the terms have to decrease in magnitude. So you must write that because all these things must be true. That's your justification to use alternating series remainder. And what this says is this approximate right here, I'm wrong by, the most I'm wrong by, what's called the remainder bound or the error bound, is this number right here. So what you write is you write my error, okay, is less than, and then, you know, error is actually your actual, which is f of 1, minus your approximation. I don't know what we put for approximation here. Oh, I put P1. I don't know how to do this. It's done different ways, but this is 3 terms. So you might say P of n or P of 3 or something like that, okay? Make sure you just understand this little fancy phrase is just error. And you never have to write this fancy phrase. It's just that sometimes AP will write it, all right? They'll use it for error and they'll say, find what this is. And you just need to understand, if you see that, that just means find the error, okay? Oops, sorry, this is an equal sign. This is an equal. This error is actually equal to this, okay? But that's, the alternating series remainder says that that's less than or equal to. It also sometimes is less than here, okay? The next term, so if I call this the approximate here, the next term is -1 over 50/40 absolute value. And if you wanted to, you could just put 1 over 50/40 here, because that is absolute value of -1 over 50/40. And then you have to show me that that truly is less than what they told you it is, that it should be less than 1,000, which it is, okay? So this is my justification, and this is my approximation for sign 1. So it says, what is the approximation for sign 1? The approximation for sign 1 is these 3 terms here. So let me just write it to make sure you understand. Part A, sine 1 is approximately equal to 1 minus 1 over 6 plus 1 over 120. Okay, is everybody good with that? So I've done everything I needed to do here. And then part B says, use my calculator to find my actual error. Okay, well, what's my actual error? My actual error is the sum of all of these numbers here to infinity, okay? But that's really this value minus the estimate. You agree with that? So my estimate is equal to, so just go to your calculator, okay? Find out what your approximation is. So my approximation is 1 minus 1 divided by 6 plus 1 divided by 120. Okay, so my approximation is 0.841666, okay? My actual value for sine 1, the actual value you put into your calculator is 0.84147. So let me go down here. So the actual is 0.84147. And I just subtract this. So take this and subtract this number up here, okay? And I get this error here. So this is -1.9568 times 10 to the -4. They'll tell you how many decimal places to go. And the error, you really just need an absolute value, okay? Technically, this just means move the decimal over 4 places. So that's 0.001956. And this is my error, okay? A pretty good error, right, guys? Not bad for just estimating by hand. Okay, so that is alternating series remainder, and all it is really, guys, is knowing that you can use alternating series remainder with your Taylor series. Okay, so another thing they can ask you, instead of sine 1, instead of just finding sine 1, is to find what this thing is, this integral of sine x squared, okay? And tell me how far I am if I estimate this from my actual value, okay? So in the first question, we found sine 1. Here we're finding this. So let's just find, it says find in series form, find the antiderivative of sine x squared. So I'm trying to find the antiderivative of sine x squared from, is that 0 to 1? From sine 0 to 1. Okay, well, how do you do this? Well, first, you need to know what sine x is. Okay, so sine x, we already know, oops, that's not right, is x minus x, that's not right, x cubed over 3 factorial plus x4 over 4 factorial minus x, nope, that's not right, sorry, x5 over 5 factorial minus x7 over 7 factorial plus dot, dot, dot. How do I get sine of x squared? Actually, we can't substitute unless we know that the function and the center shift together, right? The function is going from x to x squared. So what kind of shift is that? A 0 shift. This one, it doesn't say that this is a Maclaurin series. So actually you can't substitute, but I just want to say, we're just going to assume it's a Maclaurin series. They don't say that it's not, and it's too hard to do it without. So this should actually have specified Maclaurin, but I'm just going to assume that this also is a 0 to 0 shift, okay? A 0 to 0, which is a 0 shift. That's an assumption here, okay? So let's go ahead, because I don't know what the center is anyway. So everywhere there's an x, I'm going to replace that with x squared. Guys, make sure you understand, this is a quantity x squared, okay? You're not just squaring the thing, it's a quantity x squared, okay? So what I get is sine of x squared is equal to x squared minus x to the power to a power, which is 6 over 3 factorial plus, this is going to be x to the 10 over 5 factorial. This is x to the 14, I think, over 7 factorial plus dot, dot, dot. And I want the integral, right? The integral of this thing. So you take the integral of this side, the integral of this side from 0 to 1, from 0 to 1, okay? Since I take the integral, I don't need a plus c, okay? If I didn't have a limit here, I would need a plus c. Like, since I have limits, I don't need a plus Charlie. But since I have limits, if I didn't have these limits, I would need a Charlie. Okay, so I'm going to find what this is. You integrate this, guys, so that's x cubed over 3 minus x7 over 7 times 3 factorial plus x11 over 11 times 5 factorial minus x15 over 15 times 7 factorial plus dot, dot, dot. And now I have a win bar. Is everybody good with the win bar? So that's from 0 to 1. You have a win bar if you have limits here. If you don't have limits, you'd have a plus c. Okay? So then what they're saying is estimate this, okay, and make sure the estimate is wrong by no more than 1 over 1,000. Okay, so let me go ahead and finish this win bar. If you plug in 1, you get 1/3 minus 1 over 7 times 3 factorial plus 1 over 11 times 5 factorial minus 1 over 15 times 7 factorial plus dot, dot, dot. If I plug in 0, I get 0. You guys okay with that? I get 0 minus 0 plus 0 minus 0. So that's 0. And then I slap a minus sign between, but that's pretty, I can just ignore that. Okay, so if I plug in 0, I don't really get anything substantial. Okay, so what I get is the integral from 0 to 1 of sine x squared dx is equal to this. I'm going to approximate this. But if I use the alternating series remainder, what has to be true? The terms have to alternate. The terms have to have a limit of 0. And the terms must decrease in magnitude. Guys, you have to write that. That is your justification. Are all these things true? Is this an alternating series? Is everything decreasing? Yes. Is the limit going to 0? Yes. Okay. So then what happens is I find these values down here. This is 42. This is, 120. What is it? 1320. Okay. Oh, can I stop there? I can, right? Because I wanted 1 over 1,000, right? Okay, so I'm going to put a bar right here because this already here is less than 1 over 1,000. Okay, what does that mean, guys? That means, guys, this is my actual value. This right here is my approximation, also called your estimate. Okay, this right here is called your remainder, also called your error. Okay, but just this term right here, just this term is called my error bound. Okay, meaning, or my remainder bound, the bound of my remainder. And what that means is if I approximate this integral with these two terms here, the most I'll be wrong by is this number right here. So what that means, using the alternating series remainder, is my error is less than or equal to, and you can also just put less than here. Okay, the absolute value of this, which is 1 over 1320, and that's less than, make sure that that's less than what they asked you, 1,000. Okay, my estimate, okay, because they do ask you to give the estimate, I think, would be 1/3 minus 1 over 42, whatever that is. I mean, this is, you can leave it like this. This is the accurate method, an actual value, okay? If I want to know the estimate, or if I wanted to approximate it, okay, what you would do is the actual value, okay, so the actual value, oops, sorry, is going to be your left side here. So the actual value is the left side here. The approximate value, oops, okay, this should be a squiggly. Guys, I'm trying to, this should be a squiggly because, guys, this is the approximate value. The approximate value is 1/3 minus 1/42, because everybody goes with the actual versus the approximate. So if I wanted to know my error, you just go into your calculator and put these numbers in. So this right here would be a math 9, okay, of sine x squared from 0 to 1, sine of x squared, okay, don't forget your dx. Okay, I get 0.310268 dot dot dot, and then 1/3 minus 1/42. Okay, let's see how close I am. This is 0.309523 dot dot dot. Subtract them. So I'm going to subtract, move up here, subtract this number right here, get the difference between them, and I get so my error, the absolute value of my error, is equal to, or about equal to, 0.0007445. Okay, and they'll tell you how many decimal places to go. If they don't, going 3 decimal places isn't going to help you. Do you see that? Or I guess maybe you'd say, yeah, 3 decimal places isn't going to help you. They'll tell you where to go, and that's your answer. Okay, that's my actual error. Any questions on how to do this? All right. If it makes sense to you, it's a lot easier. If you're just memorizing things, then it's a lot harder to understand. Okay, let's look at this problem. This problem I usually give on the test every year. I haven't made the test this year. These tests this year have been different. But let's look at how to do this problem. There's something similar to this that came up on an AP test, not exactly like this. Okay. First, they say find the 3rd degree of e to the x. That's easy. Okay, it's Maclaurin. So I say, okay, e to the x is just like cosine and sine combined, but with no alternating signs. So it starts with x to the 0 plus x to the 1 over 1 factorial, actually over 0 factorial, plus x squared over 2 factorial, plus x3 over 3 factorial. You really just put all your numbers in, okay? But x to the 0 over 1 over 0 is really just 1. X to the 1 is really just x, okay? So that's your 3rd degree. Okay, don't put the 4th degree because I don't want that. Everybody good there? And technically, this should be a squiggly because e to the x is only equal to this if you go to infinity. It's not equal if you just take the first 4 terms. Right, use this answer to find this limit, okay? Now, at this point, I want you guys to tell me what to do because there's multiple ways to do this problem. And what I do may not be what you see to do on a test, okay? So guys, tell me what to do next. This right here is f of x. So this right here, I'll say is equal to f of x because they're saying find the 3rd degree polynomial. So this is f of x, the 3rd degree polynomial, okay? So tell me what to do next. Subtract 1. Okay, so I'm going to take this f of x, I'm going to subtract 1. So let me just subtract 1. You guys agree subtracting 1 just means tack it to the end, right? It's not subtracting 1 from every term, which for some reason students want to do. Okay, tack it to the end. So do you see those cancel out? So I get x, I get the limit as x goes to 0, don't forget the limit, plus x squared over 2 factorial plus x cubed over 3 factorial over 2x. You guys with me so far? Okay, at this point, I need you guys to tell me what to do because, again, I do something different from you guys. So you guys tell me what to do, and I will work it with the way you do it. Okay, you want to divide everything by 2x. Okay. How about just dividing everything by x? Well, okay, I'll do what you said. Sorry. Okay. Okay, I'm trying to learn obedience here. Okay, I'm going to divide everything by 2x. Okay, so this will give me the limit as x goes to 0. Okay, of x divided by 2x plus x squared over 2 factorial divided by 2x. But if you divide by 2x, you're really multiplying by 1 over 2x, right? And this will be x cubed over 2x times 3 factorial. I'm dividing everything by 2x. So this is a limit as x goes to 0 of 1/2 plus x over 2 times 2 factorial plus x squared over 2 times 3 factorial. Okay, no one's ever asked me to do that before, but that's okay. That's actually, I would do that. I would actually divide by x, not 2x, but no, that's okay. Everybody good there? Did you guys see what happened? You actually get the same thing. So what is the answer? 1/2, okay? Because when you plug in x is 0, you're going to get 1/2, okay? So make sure you know how to set this up. Really, you're just substituting right into this thing. Don't get intimidated by a limit, okay? Do exactly what they say, and things will work out nicely. All right. The next thing I want to do is just point out, actually, let's skip the next problem. And I want to do this one. These two problems are similar. The next two problems are similar. I just want to do something a little bit harder. Let's just do this problem and then you guys can, actually, you can go to the other problem if you want, or you can skip it. They're very similar, okay? What I have is two things here. I want to find sine of x plus pi over 6. But the thing is, one, the center is 0, and one, the center is negative pi over 6. The centers are different. Make sure you understand. This is not x equals. This is the center. So if I had to write a Taylor series for this, okay, which one can I plug in? You do the substitution. You know what I'm saying? Okay, because I know sine x. I know that series, okay, that Taylor series. That's x minus x cubed over 3 factorial plus x7 over 7 factorial minus x9 over 9 factorial plus dot, dot, dot. This center is 0. And what I want to do is I want to know sine. Yes. Oh, thank you. Okay. So let me just change. I don't think I have to go that far. So I'll change these to 5 and 7. Okay, thank you for pointing that out. And then right here, guys, x is going to be x plus pi over 6. So what's my shift here? What's my shift? Left by pi over 6. Okay, this one, the Maclaurin series is center of 0. I want to move to a center of 0. What's my shift here? 0 shift. Question, do the function and the center shift together? No, no substitution. Guys, look at this one down here. This one down here. This one is a shift from x to x plus pi over 6, and that's left pi over 6, right? This one's going to be a center from 0 to, ooh, wait, is that right? Oh, that's negative pi over 6, yeah. So center from 0 to negative pi over 6, and that's a shift of what? Left pi over 6. So this one, can I substitute? Yes, okay. Can substitute here, okay, but not substitute here. Does everybody see the difference, okay? So let me go ahead and do this one up here, just so you understand how to do this, okay? This one would be, well, let me ask you. If I can't substitute, how do I find a Taylor series? You have to do the table, okay? So you start with what you have. F of x is equal to sine x plus pi over 6. Then you take the derivative, okay? The derivative of sine is cosine of the same thing, but you have to multiply by the derivative of the inside, but that's just 1, so not a big deal. Okay, then you take the second derivative. The derivative of cosine is actually negative sine, right, of u. You also have to take the derivative of the inside, but that's just 1, so I'm okay there. And then the third derivative is going to be negative cosine of x plus pi over 6. And I take the derivative of the inside, and that's just 1. Okay, then on the right side, what do I plug in? 0. I plug in the center. So this is going to be sine of pi over 6, which I think is pi over 6. Is that square root of 3 over 2? No, it's 1/2. Thank you. And then plug in 0 here. So that's going to be cosine of pi over 6, which I think that is square root of 3 over 2. Okay, then the second derivative, this is negative sine of pi over 6, which is negative 1/2. And then the third derivative, which is negative cosine of pi over 6, which will be negative square root of 3 over 2. Then what you do is you plug in into the Taylor series. So what this is saying is sine x plus pi over 6 is approximately equal to the Taylor series, which is f at, you plug in your 0 plus f prime, I'm sorry, you plug in your center, which is 0, okay? And so then you just put this into the Taylor series. And I know some of you guys are like, Ms. Chang, I can do this without writing all this. But I'm writing this because two things. Students always forget this term right here. I don't know why. Okay, you always forget this first term. You want to jump right into the derivative, but you're not allowed to. There's an extra term here. So what I get is sine x plus pi over 6 is about equal to 1/2 plus the square root of 3 over 2x minus x squared over 2 times 2 factorial minus the square root of 3 x to the third over 2 times 3 factorial. And then I just need 4 terms, right? So plus dot, dot, dot. And this is what sine x plus pi over 6 is equal to, going to the having 4 terms. Is everybody good with that? Okay. On the bottom, since I could actually plug in, okay, on the bottom, since I could actually plug in, what you do is you take sine of x, and everywhere there's an x, you're allowed to plug in x plus pi over 6. So this would be sine of x plus pi over 6 is equal to x plus pi over 6 minus x plus pi over 6 raised to the third power 3 factorial plus x plus pi over 6 raised to the fifth over 5 factorial minus x plus pi over 6 raised to the 7 over 7 factorial plus dot, dot, dot. 1, 2, 3, 4 terms, okay? So it's way easier to substitute if you can, but you're not always allowed to substitute. Okay, is everybody good with that? And if you wanted to, just for fun, you could do the table here and you would get the same answer, okay? All right, let's do another problem. Let's move to number 7, please, on your homework. Okay, so we're going to try to do 7 and 8 together on your homework. We'll do as much as we can. And if we don't finish something, then I'll just leave it to you guys to do. All right, number 7 says write sine x squared. We're going to write sine x squared. And I like that, let's see. It says the general term of Taylor's series sine x squared about x equals 0. I like that they said the center, okay? So guys, the center, the function is going to shift by 0. Do you guys see that? And the center is going to shift by 0. I'm going to start with my Maclaurin series, okay? So I'm allowed to substitute in, okay? So let's substitute here. If I substitute, I'm going to have sine x squared is equal to, everywhere there's an x, I'm going to substitute x squared. Actually, let me write it out because this can get really wrong really fast. Okay, so there's my first 4 terms, plus dot, dot, dot. They also want the general term. So let me also put in the general term. We need practice with that anyway. So everywhere there's a, oh no, this one I memorized. So guys, it's an alternating term. So I put -1 to the n. The x, it's an odd exponent. So I put 2n plus 1. And this exponent is the same as the denominator. So I put 2n plus 1 factorial. Okay. This is a substitution. So what I do is everywhere there's an x, I put in x squared, okay? So if you squeeze x squared in there, make sure you understand, guys, it's a quantity substitution. You are not just merely squaring, okay? You're actually substituting in an x squared. You get a power to a power. So I get x6, I get x10, I get x to the 14. And over here, this is also a power to a power. So what are you going to do to the exponents here? I'm going to multiply by 2, right? So that's where I'm getting the 4n plus 2. But does anything change in the denominator? No. So you keep that 2n plus 1. All right. The next question says, g prime is sine x squared. Okay, so this right here is equal to g prime. Okay, and it says, given an initial condition, write the first 5 non-zero terms and the general terms of g of x. So guys, if I have g prime and I want to move to g of x, what do I have to do? Integral. So what I'm going to do is I'm going to integrate both sides. Okay, so I'm going to integrate this side, and I'm going to integrate basically this side. So what I get is the integral of g prime of x dx is equal to the integral of this right here, okay? So basically you take the antiderivative. Does it have a win bar? It doesn't have a win bar, so I'm gonna have to have Charlie. Do you guys see how that works? Okay, so this right here, well, let me just write it and take the integral of that. So the integral of this is actually g of x plus Charlie. Okay, I can move Charlie to the right if I want to. I can keep Charlie on the left, but there's going to be a Charlie on the left, there's going to be a Charlie on the right, and I'm just going to combine them and make one Charlie. Do you remember we've done this before? Okay, so on the right side here, this will be equal to x cubed over 3 minus x7 over 7 times 3 factorial plus x11 over 11 times 5 factorial minus x15 over 15 times 7 factorial plus dot, 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 plus, okay, let me get my general term in here. I should have moved a little bit more over to the left. Okay, so I'm going to try to see if I can squeeze my general term in here. I did use x. Why didn't I use? Say that again. What do you want me to use? Oh, sorry. Okay, you're good. Okay, no, I do things wrong, and okay. So this is taking the antiderivative. So what did I do to this general term to take the antiderivative? Yeah, add a 1. Is it still alternating? Okay, so I still keep this -1 raised to the n. Okay, but you add a 1 to this term, this exponent. So that turns to 3. Okay, then do you see I have this extra number in the denominator? Isn't that number the same number as the exponent? So you're just going to copy that exponent. Okay, and then this 2n plus 1, does it change? No, so then you just copy the 2n plus 1. Okay, there's my general term. And sometimes you can simplify this general term. This general term is not unique. All right, so this is what I get on the right side. So I have g of x plus c. So let me just write this. Just as g of x plus c is equal to all of this, okay? I do have a plus c on the right also. Just make sure you understand. I have a plus c on this side. This is a 1 and this is 2. I have a constant on this side, a constant on this side. So you guys okay if I combine, this is a plus, both constants, okay? And I'm solving for g of x, okay? A lot of times I just put the g of x on the on one side. So is everybody okay? I'm going to combine the constants and put it here. I'm going to put it at the beginning instead of the end, because if I put it at the end, I'm going to forget it. Okay, actually, this is plus dot, dot, dot. Okay, guys, this is my answer, but I have a problem. I don't know what C is. How do you find C? You go to your initial condition. Do you see your initial condition here? So that means every time x is 0, put in 1 for g. So this will be 1 is equal to c plus 0 minus 0 plus 0. Okay, what's c going to be equal to? 1. So all you do is you cross this out and you put a 1, and that's your g of x. Do you guys see how these problems work? Okay, if you don't have limits on your integral, okay, you have to have a c. The problems we did before, we had limits on our integral, okay? So you didn't have a c, you had a win bar. But here you have to have a c. Okay, are we done with number 8, or is there another part? We're done. Number 7, we're done with number 7. Okay, let's go to number 8. Okay, so number 8 is similar, but there's a little bit of a twist in it. Okay, so first, number 8, you have to get the first 4 terms of this expansion. All right, so let me just do it with you guys. Okay, you guys have done this on your homework, but we haven't actually done one together, so we might as well do it together. There's no substitution that I can do for this, so let's just do a table. Here we go. F of x equals 1 over x minus 1, which is really x minus 1 raised to negative 1. So the derivative of that is going to be negative x minus 1 raised to negative 2. You also have to take the derivative of the inside, but that's just 1. Okay. The second derivative is going to be 2 times x minus 1, take the power down by 1, multiply by the derivative of the inside, but that's just 1. The third derivative is going to be 2 times negative 3 is negative 6, x minus 1, take it down by 1, multiply by the derivative. And how many terms do I need? Just 4, so I'm going to stop. You might have to put in another term if something's 0, but I'm going to take a chance. I'm going to plug in my center. My center is 2, so this will be 1 over 2 minus 1, which is 1. My center is 2. So this is going to be, this is negative 1 over x minus 1 squared. Let me rewrite this. This is 2 over x minus 1 to the third. And this one is negative 6 over x minus 1 to the 4. Okay, so when I plug in 2, I'll get negative 1 over 1, which is negative 1. When I plug in 2 to the second derivative, I get 2 over 1, which is 1. Oops, sorry, that's not 1. 2. And then when I plug in the third derivative, I get negative 6 over 1, which is negative 6. Can you guys check me? Did you get 1, negative 1, 2, and negative 6? Okay, then you just put that into your Taylor expansion. So that means 1 over x minus 1 is approximately equal to, okay, first you put in f at 2 plus f prime of 2, x minus 2 over 1 factorial plus f double prime of 2, x minus 2 squared over 2 factorial plus f triple prime at 2, x minus 2 third over 3 factorial plus dot, dot, dot. Okay, I put a squiggly, so I really don't need that plus dot, dot, dot. Okay, I'm going to substitute all my coefficients in. Okay, so what I get is this one right here is 1, this one's negative 1, this one's 2, and this one's negative 6. So 1 over x minus 1 is equal to 1 plus, we're going to do squiggly, is about equal to 1 minus x minus 2 plus 2 times x plus 2 squared over 2 factorial minus 6 times x minus 1 to the third over 3 factorial plus dot, dot, dot. Guys, do you see what's going to happen with all of these things right here? The coefficients are going to go to 1. Do you guys see that? So this ends up being, here I have it here, 1 over x minus 1 is about equal to 1 minus x minus 2 plus x minus, oh wait, why do I have a plus 2 here? Sorry, this should be a minus 2. This should be a minus 2. I don't know why I have a plus 2 here. So x minus 2 squared minus x minus 2 to the third plus x minus 2 to the fourth. Do you see how this is going to work? So if I did a general term here, do I have alternating signs? Yes, so I need to put in the alternating signs. Okay, make sure it works. So if n is 0, if n is equal to 1, I get negative. Good. And then it'll be x minus 2 raised to the n. And I think that's it. No denominator. Okay, you guys good there? All right, the next question says take this thing, okay? Take this thing and figure out what ln of x minus 1 is, okay? So, oops. So take this thing that I have. So I'm going to copy what I have here. Try to pull this. Oops, why do I keep grabbing that? Okay, so I'm going to remove all these little things here. Okay, do you guys agree, like the green that I have there is what you guys have on your paper, right? Okay, so what I'm going to do is I'm going to take this, and I know f of x is equal to 1 over x minus 1, okay? So this is equal to 1 over x minus 1. How do I get log of x minus 1? Yeah, you have to integrate it. So this, just make sure you understand, this is equal to 1 over x minus 1, right? If I want to move that to the log of x minus 1, really plus c, okay, what I have to do is integrate both sides. So come over here and integrate both sides. Okay, so you have to see that. You have to say, well, how in the world from what I have would I get log? Oh, I integrate both sides. But if you integrate both sides, you need a Charlie, okay, unless you know the wind, unless you have a wind bar, and I don't have limits here, okay? So that means ln of x minus 1 plus Charlie is going to be equal to, and then just integrate each of these. The integral of 1 is going to be x, okay? I'm going to do pattern recognition here, guys. The integral of x minus 2 is actually what you do is you add 1, you divide by the new exponent, which is 2, and then you divide by the derivative in your parentheses. So that derivative is 1. So this right here is going to be x minus 2 squared over 2. Okay, you guys can do that your long way if you'd like to. You should get the same answer. So right here, I'm going to take the integral of this. What you do is you add 1, divide by the new exponent, which is 3, also divide by the derivative of the inside, which is 1, And so what I get here is plus x minus 2 raised to the third over 3. Again, I add 1, divide by the new exponent, divide by the derivative of the inside. So I get minus x minus 2 raised to the 4 over 4 times 1, which is just 4. Okay, all of these plus dot 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 plus. You do the same thing to your general term. This is still alternating, so it's negative 1 to the n, x minus 2. I add 1, so this would be n plus 1, divide by the new exponent, which is n plus 1. Okay, so this is what I get. I actually need Charlie here. I'm going to add Charlie to the front. Okay, guys, I don't need 2 Charlies. Is everybody good with that? So I'm just going to combine Charlie all on the right side. It doesn't matter if you combine them on the left or the right, but that's what I get. And then the question is, find ln of x minus 1. Guys, this is it. This is ln of x minus 1. But how in the world do I get rid of Charlie or find Charlie? Plug in. How did you know to plug in 2? But what it is you plug in the center, okay? You plug in the center because there's something I know about Taylor series. Anytime you plug in the center, the Taylor series always converges right at the center. You're always exactly right at the center. So guys, that means this side is equal to this side at the center. So plug in 2. If you plug in 2, look at what happens. What do you get? Right? You get this ln of 1 is equal to c plus 2. So what do you get here? 0 is equal to c plus 2. So what's c equal to? Negative 2. So what you can do is come up here, put in negative 2, and that is your value for ln of x. It's a little tricky here, and I think this is very ambiguous. I don't like this. It says plug in the first 4 terms. So if you count 4, 1, 2, 3, 4, you could cross out this term if you wanted to, okay? If you change this to x minus 2 and you called it that, then I feel like you could actually count this term as a whole term. But either way, I don't think the AP is going to be picky about that. They're picky on the degree, okay? When you look at number of terms, there's different ways you can define number of terms. C, I think, says to find the ln of 3 halves or something like that, right? Okay, so find the ln of 3 halves. Okay, you guys know that this right here is equal to the ln of x minus 1, right? So if I wanted this, and you put a 2 there, if I wanted this to be the ln of 3 halves, what's x have to be? 5 halves. So all you do is you put 5 halves here, you put 5 halves here, you put 5 halves here. Does that make sense? And that'll give you an estimate for ln of 3 halves. And then part C says, once you put all these numbers in, go use the alternating remainder series for that, okay? And I think you guys can do that because everything is a number now. Go find where you're less than, I think it's 1 over 1,000 or something like that. 1 over 20, sorry, 1 over 20. Go find that, okay? Plugging in that x is equal to 5 halves.